Welcome to today's webinar. We are delighted to have Christian from Moving Products with us. I'm Agustina Jaime. I'm part of the McNeil team in Europe. We're based in Barcelona. I'm an industrial designer myself, as Christian is. And he will guide you today through optimizing your data preparation workflow and efficiently managing frequent CAD updates. So our speaker today studied industrial design in Munich, specializing in mechanics and animation. And he has taught Rhino, Keyshot, Cinema 4D for over 14 years and is the founder of Moving Products. So it provides Moving Products B2B design services, develop parametric tools for clients, and creates high-quality animations and configurators. That is gonna all be shown today. The company leverages Rhino as a core modeling tool and center stage for CAD data preparation. This way, it ensures seamless translation for rendering. So as all our webinars, feel free to use the chat to ask any questions to Christian, and we will have around 15 minutes, 30 minutes, as long as it takes, at the end of the webinar to ask him any questions. If I can answer them, I'll do it through the chat. This webinar is being recorded and we will put it in our YouTube channel, and everyone will get more information, a follow-up email during these days. So thank you so much, Christian, for your time, for being here, and thank you everyone for joining us. Whenever you're ready.
Thank you very much for inviting me, Agustina. Thanks for the invitation. And thanks to the Rhino community. I hope I can give something back today to all the tutorials I was watching during the time I learned. So I hope you can see my screen as planned. So I'm going to talk about data preparation. It's never been my favorite subject, but it is something I always stumble upon. If it's not done right, you get in trouble later in the project. And Rhino was always for me a tool to get the mixture of all worlds, the engineering world and the design world, together. So just a short overview of what I'm usually doing. Usually I'm in the design business, creating machinery. Of course, I had to learn Rhino to model stuff like that on a very simple basis. And I also started animating quite early during my student times. And I was heavy into complex machinery, meaning all the movements, all the processes to animate them for my clients. And doing all that get me used to very heavy data sets and also very complex engineering tasks where you, well, not engineering, but, you know, the visual engineering. For example, this was a project for Red Bull where we had to rebuild the whole Formula One car because they didn't want to give us any data because it was so secret. They just gave us some pictures and remodeled the whole car. So I'm very used to heavy data sets in the big gigabyte numbers where you have the whole car, whole everything with all the screws. And Rhino was always my favorite tool to chew through that, separate that, and make renderable files out of that. The project that I'm going to talk about mostly today is a configurator for Koenigsegg, the new Gemera. And we were asked to create a configurator. That was basically the whole briefing. And we knew that Koenigsegg has a very small number of clients. And we knew that these clients were all over the world and they needed high quality, speedy access to the configurator. And Koenigsegg was not really happy with the old WebGL configurator they had. And so we decided to go in the pixel streaming direction. So that was basically the plan: take the data we get from Rhino, or collect the data we get in Rhino, make a basic setup, or just a setup in Unreal, and then over pixel streaming, we can send it to all the stakeholders in the company, because it's a very speedy process to do the car modeling, which means that the design offices basically working on their own, and they need input from all other shareholders in the company. But to provide them with renderings and data is very complicated. So the streaming was a tool to get the status of the car to everybody in the company. So including marketing, production, and they could look at the first views of the car and give their 2 cents to all things. And especially very interesting because there are some very analog people in the company as well. Like they have a gold guy who's doing all the gold stuff, or the leather guy, and they don't really use computers. So you need to get them into the car and make them watch the car. So there was a dead end in this process because we needed the high quality UV layout for all the carbon files. In this example, you see a carbon rim, and we tried to get the UV mesh out of Rhino of this carbon rim, for example. And just to show you the progress we made there, it didn't really work. Rhino had big problems separating meshes at very, very small complications in the mesh. And you could either make a very complicated fix to do that, or we go the normal route, which we did is go to a separate program and do the UV mapping there. So I was used from animation days from cinema, for example, to do this workflow you see in the picture here. We got data from very different kinds of input programs. So there was the design part of the company who did the surfacing in Alias, for example. They had soft parts that they did in Blender. We had the rims, for example, or the tires coming out of Blender. We had some engineering data coming later into the project. And we could assemble all of that in Rhino because it's a very good tool for that, to get all files to work in Rhino, basically. And then my usual way to do was you get the file into MOI, Moment of Inspiration, because it had the most beautiful quad remesher or quad exporter tool. And then you get it into something like Cinema for meshing, for bone structure, for rigging. You get it into Rhythm UV for very beautiful UV map, and for example, Blender to do some additional modeling or something like that. And then you go to Datasmith and get it into Unreal Engine. Now, it sounds complicated. It is complicated, and we learned a lot in the process, because what we thought that it's like, okay, here's the car and we need it in the configurator, turned out to be a very, very complicated process in the company. Because, and I think that's a little story time, when Koenigsegg first showed the Gemera, it wasn't a ready car, it was ready for production. What they usually do is they create a model, they sell the possibility to buy the model to the customer. Then when they have sold most of the cars, they start producing the car. And during that time, production, a lot of things can change. And they do change because it's the company's heavily focused on doing the greatest car that they can possibly do. And Christian von Koenigsegg is very known to come into the room, have an idea about how to improve stuff, and then they just have to change the whole car. So they still keep on changing the car, although we are very, very late in the process of the configurator. And what we thought was in like a one-way street of us getting the car, preparing the data, and then showing it to them, became a very, very iterative process. Basically remodeling the half of the car every few days. And that just didn't work with the workflow we had there. And the breaking point is basically tessellation. As soon as you tessellate, which means going from NURBS data to fixed polygon data, you break the process into like your construction data and then your animation data. Because we needed tessellation for the UV mapping, we needed tessellation to make the rigs in Cinema, for example, for the door hinge, stuff like that. So that was the idea, that we have to do that. There's no other way for us. And tessellation definitely turned out to be the biggest breaking point, although it's also the mightiest point if you have the data, because if the customer tessellates for you and you get a bad tessellation, meaning like a low resolution mesh, it's impossible to work with it. It's impossible to get like the back sides of files out or something like that. It's very hard to work when you get the tessellated data, so you have to do the tessellation yourself. Otherwise, you have no control over it. So this became the key point, and problem with that was we had to tessellate. We had to go to the next program, Prism UV, for example, so that we could do the UV mesh. But if you extract UV meshes from NURBS data, you don't get like nice edge loops you would get in subsurface demodeling, sub-demodeling. If you would model in Blender or something like that, you get these tiny triangles. They often give you the problem that you cannot separate the path of a UV island. So for example, if you have a corner and then you have the fillet coming there, like you have in the rim here, it's very hard for the automated process to find exactly where the fillet used to be, because you have these tiny little angles here, and they don't know which way to go basically to follow the path. There's no fine loop. So the hope was, we have these separation lines for UV islands in Rhino. Why can't we use them? You've seen the problem with the UV mapping tool at the beginning. And we were talking to McNeil to help us fix that problem. And thanks to the people at McNeil, they helped us and updated the UV separation system, so that we could finally get all the separations and all the deformations we needed inside Rhino. So this wasn't possible prior to that, because we ran basically with every part into the same problem. There wasn't any part that would be separated nicely. And after the fix they provided, I think it's in one of the last updates of Rhino, it would be integrated. We could finally separate our UV islands the way we needed. And the UV tools in Rhino are not like there's not a ton of them. There's very few options you have. But the good thing is that you can use all the tools that you can find in Rhino for mesh manipulation. So for example, here I separated all the parts of the rim, laid them over each other. So you have like all 8 or 6 parts of the rim. And what you see here, it's a little bit deformed, but you can use all standard deformers to work on the UV mesh as well. Although you only have like these 3 constraint tool button there, it's no problem to use all deformation tools on the UV mesh, so that you can create fine UV meshes the way you need them. So I tried to show you a little video how I did it, for example, from one of the center consoles, so that you have an understanding how if you have never used them, because most of the time they did not work to completion, maybe you find help here. So one of the key things I found out is for quick separation of the parts, or quick finding the loop online, you can have with Control-Shift mark the first and then the last edge you want to separate, and then double click in the middle of this loop, so you can have your the line that you want to straighten out, for example, separating the 3 clicks. And what you see in the video, you need an unwrap method for that. If you don't have an unwrap method, it won't work. And also there's kind of a bug right now in the system, that if any of your files or UV islands doesn't have an unwrap method, it won't work again. So what you see here, I cannot use the constraint tools unless I update the unwrap method for all UV islands, so that I can go on and use, for example, the path tool here to provide a path for my UV mesh. So this helps a lot to get the constraints working again. There are still some issues with that, but it was good enough for us to get these quite complex parts basically scratch-free into our Unreal configurator. So just some final touches here. And yeah, so get next there. I was able to unwrap basically the whole car in quite good fashion, I think, which wasn't possible before. And I'm very thankful for McNeil that they helped us with that, because after that we could finally approach a master file where everything for the data preparation was done in Unreal in Rhino, and we didn't need any third-party plugins or third-party programs to do that. What also helped is if you do the UV separation in the NURBS data, it's really great because you have the UV mesh on the NURBS data and not on a saved polygon data, the tessellated data. So you can remesh and change the mesh after you did the UV meshing. So you have your high quality mesh in Rhino. And if you transport it, usually you would say, okay, I save out the rim, I make it polygonal, I tessellate it, and then I open it in Unreal. And I found out that some polygons are not perfect there. The resolution is not high enough. You would have to go back to Rhino, change that, do the unwrapping again, and then go back to Unreal. We did that at the beginning, and it was very expensive to do that again. And after we found out that Koenigsegg is changing their data every few days, it became clear that it was way too expensive to go this way, because I needed to send the data to a guy who's doing unwrapping. He was very specialized in that. It was a great product at the end. So we had beautiful UV maps, but we couldn't do that every few days since they changed the data too often. So this way, we had the unwrapping in Rhino, and we could also do the tessellation after the fact that we did the unwrapping. So what you see here is you can go back to Rhino, and with a custom mesh, you can change the resolution of your NURBS data, of your tessellated data, and it will keep the UV mappings. Basically, you can do LODs or level of detail inside Rhino, and so you can control the quality of your mesh for every part separately while exporting that. So instead of creating too many FBX files, OBJ files, like in the last workflow, what you see here, this made it able so that we could have one master file, the whole car in one file, which was quite a big file. But what you could do is you can save out separate chunks of the mesh and do the import process. I will show to you how the import process works in a second. I think what's very helpful is that you can use blocks or parts of the file without needing those files again. So you can save out a part of the car, import it into Unreal to save time during saving, importing, and just disregard the file again. It wasn't possible before that because I had to keep all the imported files. So to not bore you with cars all the time, I made a little toy. You see, I did all the unwrapping in Rhino. And what you can do is you can give these parts or the layers names, and you can use Unreal to map these names, either the file name, the object name, or the layer name, to change either the material or merge it together with something else, or put in a separate group for further development there. Yeah, so just for everybody who hasn't done that before, if you want to do the import process in Unreal, you have to make sure that you activated your Datasmith plugin, which you can find under plugins and just search for Datasmith. They do have a real-time plugin with Rhino. I would not use that for bigger projects because it's just very easy to just hide something in Rhino and it won't get transported to Unreal, or you get a complete rebuild of the data if you just change a minor detail and it takes forever. Also, you don't have these many import options if you use just the normal import. The normal import would be the one you see here. If you go on import stuff in Datasmith, you can get a file import, but it will just give you the imported data as is without any recipe that you can put on the data without changing it, without replacing stuff. So the better way to do it is to go to your content browser, right-click and get a data prep asset, create a data prep asset, and then you can do a recipe, how to control the data that you created and import it, and how to use it further. So there's a very big caveat here. It took me forever to find that, and I couldn't read about anything in that. You have these little options here that I did always miss. If you click on that, you can say that it should import Rhino meshes and UVs. The standard is to import NURBS and create the mesh in Unreal. That would lose you all the UV maps you did. So I tried several times to get the UV maps in it, and it never worked until I found this little button. If you import the Rhino meshes in UV, you will keep your UVs and they don't get destroyed in the process. So that's a very important button. Here you see the data recipe that you can put up with the data preparation asset. You can search for the file names, you can search for the layer names and stuff like that, and you can use this to either merge them or replace them or automatically give them a material. I just made a little simple process here. It's just a drag and drop action. So you drag the action that you want all the parts that contain red, merge them together and give them a red material, for example. This will create meshes for you, and it will merge the meshes and give them one material. And then you can put it out under the name red, for example. So the good thing is you can make this recipe once, and then you can import all the different files I just told you before. So you can just put a small chunk of the big file you have in there, like you can make a block for the wheels, and then you just import the wheels, and they can process it with this recipe without losing all the other data. So basically you have your master file, and then you can just take out parts of the master file or the whole master file and import it to Unreal. You don't have to remember export settings. You don't have to remember import settings. You just take the master file, put it through the recipe, and you will always get the same result, which is a very handy thing because if you change stuff in Unreal, it would be very helpful that the underlying mesh gets changed, but the change you did in Unreal will stay the same. So what Unreal does is it has an actor for each part, and each actor has a mesh integrated. And when you do this data recipe, you change the mesh, and the mesh automatically gets updated into the actor, and everything you did with the actor, which is like a stand-in, a null point, a pivot, will stay the same in Unreal. So this is a very helpful approach because since we had to change data sometimes on a daily basis, sometimes on a weekly basis, because they did some changes, they needed customers to see it as quickly as possible. We had to do this iteration again and again and again. And we had about 2,000 moving parts in the car. And we have, I don't know, about 600-700 option groups where you have like parts that will be changed later with the color, with the materials and stuff like that. And if you change one part, you want to make sure that all the parts and all the configurator possibilities get changed automatically as well. And this is a very good way to do that without losing oversight, because here you have the names in there, and the only thing you have to take care is that the name is correct in your Rhino file, and then you can update it automatically and get all your additional settings as well. For example, you can do collision or LODs or stuff like that. So after you did the recipe, you will see on the right side the outcome of your recipe. For example, here it's just a very simple pilot. I took all the wood parts, merged them together into an object that's now called wood, and it has the material wood on it. And no matter what I do in Rhino right now, adding more parts, changing those parts, I will always get this part called wood with a wood material in Unreal, and I can do whatever I want with that without breaking anything. So there were some things that are not really updated in the documentation about that. For example, they claimed that they have rounded edges in there or stuff like that are just render engine parts in Rhino that you see rounded edges on your files, on your objects, but you don't really get them if you export them. So it doesn't really take the render mesh, because the render mesh you see on the screen is already a post-processed render mesh. You get the render mesh before all these post-processes are added into Unreal. So an additional part we did for the workflow was trying to keep everything in Rhino, meant that we also needed normal maps and stuff like that coming partially out of Rhino. So after we did the UV mapping, for example, of the seats, I could take this UV mesh. In this case, I made the outline of my UV mesh. I used this outline as a height map in Materialize. That's a free program to create height maps, normal maps, ambient occlusion, etc. out of files you provided. And I created the normal map in Materialize and just took it back to Rhino and used it in the material as a normal map so that I could get the cushion already inside Rhino, and I could have a representation of the normal displacement that I wanted to have in Unreal already in Rhino. This was, I think, quite a quick fix to go about that. It's not working for everything you want to do, of course, and there are several reasons why I want to go in a different program. But exactly for this approach, it worked very well because we could show them like we had a lot of different variation of projection of patterns. They wanted to try a lot of stuff on different parts of the car. And this was a very, very quick way to do that, because if you go through a substance workflow by creating these patterns and especially the stitches, it's just a way more complex task. You might get a very good result, but you cannot change it quickly. And for us, this was the quickest way to do that. So we could create all the normal maps directly inside Rhino with Materialize as an export, and then just show the car. This is all of that already exported into Unreal. So the stitches were made with a Grasshopper plugin and were also used as a 3D export. So we had the normal map and the stitching already shown in Rhino, and we could use the substance workflow that's also provided by Rhino that we could integrate, and we could try out the different materials that we want to use in Unreal later. The only thing that you cannot do is change parameters in substance inside Rhino and then export these parameters back into the file that you want to use in Unreal later. So what you will have to do is recreate the material or export maps out of substance directly in Unreal so that you can use those textures later in Unreal. But it was just like not really relevant for our workflow since we didn't have that many base materials. And you also wanted to create master materials inside Unreal itself, which has a very complex dynamic system. So we didn't really want to use the materials we created in Rhino. They were just for preview purposes, but very helpful to do so. Also, what would be missed out, we have, for example, the hinge, which is a very complex part, or stuff like the door, or the mirror, for example, that will clap in if you open the door. In the usual workflow, we would have gone to Cinema, make a bone rig, create that bone rig, and then export it as a FBX into Unreal. And since we didn't want to go that way, but wanted to keep everything inside of Rhino, the solution was to write some scripts in Unreal, which sounds complex, but really it's not that complex, which I now know. At the beginning I did not. I thought that sounds horribly complicated. But basically you can tell Unreal just a simple look at function where like one part is always pointing to the next one, and you can select those two actors live in Unreal without having to do some programming. So this is a little tool programmer wrote for me that I was working with in this project just to do the basic rigging. So you do the animation via actors, and then you have these additional pieces of code that just take care that all things that should point to each other all the time. And that makes a very simple rigging system for Unreal that still stays there if you change all the parts, which we did, as I said, on a very regular basis, because we started with a very simple hinge and went through all the iterations without having to change that. That would not have been possible if we would have to do the rigging and the skinning and everything in Cinema and export it back, because it's just too much of a hassle to do that every time. And I'm quite happy with the fact that we could do it like that. So that helped maintaining this one master file, because we will be working on this car for still quite some time, because they will keep changing it. And what helped a lot is that workflow in one file, because after a few weeks or a few months, you don't really remember your FBX export options or the import options in some other program, or who named which file after what system. And so we didn't need to update anything. There was one file at the naming conventions, which was very simple, like for the material, for example. And what we keep now is we have these, as I said, like about 2,000 parts, and we can just keep updating them in Rhino, export it, and then upload the packaged Unreal product and have the whole new car at every customer's place in a few hours, because mostly the uploading is the problem if you don't have an iterative uploading system. But everything else is now quite a streamlined process. And I think Rhino really helped me to do that, because it, on the one hand, it helps importing every basic file system you can get. So this is very helpful, because, for example, the tires were bought from the marketplace. The cushions came from Blender, the hinge out of CATIA, all the design parts out of Alias. There's just a great place to put everything together, and still having the control over the tessellation, because if you try to import it into Cinema, for example, at the beginning, you will lose a lot of control in the later process, because you lose the ability to tessellate later in the process. Also, I'm very thankful that McNeil updated the tools that we needed at that critical time, and that we could use this process like we are using it now. So I'm really trying to do this as short as possible for you, because I hope this is a helpful approach for some of your data projects. And I will leave you with some impressions from the configurator as it is working right now. This is real-time streaming anywhere over the world, and it's just, configurator. Okay. As always, I was running a bit through that, but hopefully that was helpful for you. Thank you.
Thank you so much. That's really, really nice. I don't know if you can see the positive feedbacks that people are giving now. If anyone has a question, we can do them now. If not, thank you so much for your time. Everyone is thanking you. I'm reading to see if there's any update or any question. But thank you so much, Christian. Thank
Well,
you for
if not, then I explained it very well.
yeah. Thank you for the nice words about McNeil and the collaboration. It's really nice to see the users. I think that's pretty much here I have a question. That's pretty much what our intention is, to not solve all the issues of all the markets, but have a really real contact with users to understand their needs and be able to improve in those workflows. And rendering is something that I feel that the community is not that much aware of the possibilities in Rhino, and I think it's great to see it in a real life case and with a professional, and understand what's Rhino's part within all other programs and all other parts of workflow. So that's why I knew this is going to be a great presentation and very interesting for the community.
Thank you. Yeah.
If you're okay, I'm going to ask you some questions because they're bombing now. And I'm not going to be able to catch up if I don't start reading them. I have first George that says, do we get a free test drive? For watching the webinar, you can start in private, and I have a positive feeling for that. I have Ibai that says, curious, how do you mark the seams for the UVs prior to making the meshes? That's a very good question.
So I think a few things. So sadly, Koenigsegg, they never have a car that's really driving, because when they start producing them, it's only a model, and they're selling them so fast that they rarely have cars for themselves to try. It's very sad. So I could sit in them, but I never could drive in one of them. But there was another question I've read before that I mentioned, materialize. I will write it in the chat. It's materialize like that. I think you can find it very easily. You can import different textures and then create, for example, normal maps or height maps or AO maps. Depending on what you put in there, you can create the rest of all these maps. And I use the height map to do that one. The seams, I think it depends on if you're referring to the stitching seams. These are projected, and I got the projections basically from design. So they sent me the pattern and the way they wanted to project it. And I projected that on my, sometimes it was sub-D, like the meshes, for example. There are different variations of the seat cushions that you can have. And sometimes we had to build them before they were made by design. So I had a sub-D workflow in there where I put some of the cushions in there and then projected the seams on it, and then did the stitching. And what you can do is you can have separate UV channels. So sometimes what I would need is, like you've seen in the file here, this is a split up mesh, so that I can have the borders of these UV islands that I can use as height map or borders. And then I can use this UV channel and map it back onto my original file, so that I have two different UV channels on one file, so that I don't have the broken one and then the real one. But depending on what you need, you won't even need to do that, because we used a triplanar mapping in Unreal, so we didn't really need the UV mapping for the cushions for the texture. So.
I don't know if that was exactly your question, Eve, but if not, you can tell us, and I'll go with the next one. Oh, he says, I guess Christoph comments on that question, and he says that I guess the question is about the UV islands, how to separate it in Rhino.
So I think I can just open Rhino for you then. what you would do is you go into your UV tools, go on unwrapping, and then what you need to do is understanding the part, like how you wanted to do it in if you would have to build it out of paper. Like you can only keep straight parts. And for example, if I would have to build it out of paper, I would cut it here, I would cut it here, I would cut it here, and then once again here. And just separate my part like this. So the nice thing about this, I can do double clicks all over because I have edges running around here. For example, like this. Separate the lid. I don't have a bottom. And when I do that, I get chaos, sorry. But basically what you get here is then one of these UV islands that you can later use to, like, yeah, UV mesh. And of course, I can go back and do another cut here because it's overlapping. Depending on what you want to do with UV mesh, you can cut it more or less and then use the methods I've shown in the video.
It's also dependent on the texture that you want to apply, the seam that you choose. If it's wood, it would be more work. You have the joints. I think it depends on the case. I copied the video.
Yeah. So as I've seen, I think the difference to Blender is probably superior in all details about unwrapping. But the thing is that you have to then, as I said, tessellate it, and then you lose the control in Rhino. You have another file you need to create. You have a roundabout you have to take, and we wanted to get rid of all of that. And it was sufficient to do all of that in Rhino. I think if you do a Dragon Rider, you don't want to do it in Rhino, but for most of the things you can do in a CAD program, the unwrapping process is quite sufficient.
I don't know if you're reading. I'll read you the next question. Have you been able to integrate the new Rhino CFD tools into your workflow? Sorry. And have they helped to overcome some of the UV mapping issues you mentioned?
So it didn't really change anything in the UV meshing. It was just easier to provide cushions, for example. But in this project, we didn't model a lot of stuff in Rhino. It was really just some cushions for the seat, and the rest is all mechanical and engineering parts. So what I did there was, for example, shadow parts so that you cannot look through objects where we didn't have any data. But that was all very simple, straightforward Rhino Geo, and we didn't really need any sub-D. I love sub-D modeling. I use it for soft parts all the time, but in this project, it didn't really matter.
So William asks, when bringing objects to Unreal with the intent of animating, are you creating a custom origin point for each object in Rhino, or are you changing the origin point in Unreal after the import?
Yeah, so that's a good question because the pivot point is not translated to Unreal. Whatever you do to it, it will not be there when you translated it. So what I usually would do is create a sphere at the point where I want, because a sphere always has the right origin point in its center. And if I want to have something, for example, a hinge turning at some place, I would just create a sphere there in Rhino because I can snap to the perfect origin point in Rhino, create a sphere there, and then later in Unreal use that sphere as a anchor point and just get all my objects under the sphere and make the sphere invisible. That was for me the easiest way to perfectly get centered points from Rhino to Unreal because the origin point is not working. Yeah.
So William says, so even though the preview is meshed right now in the UV editor, is it still technically NURBS?
Yes, it's technically NURBS. Yes. So you can still change them here. And you will get the different mesh created on the go that you can export then. And it is just a representation of the mesh you used before there. And if you do unwrap again, for example, I think it will upload automatically. But it will always take the mesh you see here in the screen that you can change in the render mesh settings in the custom mesh and translate that to Unreal. So this is the mesh that you can export.
And for final question, I have Ercom Demario. It says, designing and developing topology in a sub-D model is a very different workflow than CAD modeling. Making a true circular hole is a simple task in CAD software, but not in sub-D. Do you have any recommendation for streamlining or optimizing the communication between the two formats? That's a very...
Yeah, I would think they're completely separate, and that's a problem because I used to use Moment of Inspiration, which is a 3D program that is basically made for tablets mostly, because it has a wonderful quad exporter and you can read Rhino files. So if you have the...
Could you repeat the name of it?
Moment of Inspiration, MOI. There's just no... I can send it. Just set something to the wrong person. Okay, Moment of Inspiration. It is a wonderful quad exporter. So you can read Rhino files and export quads out of them, which might help you with getting like circular holes in there, because you need basically a quad to put a hole in there. Otherwise you get bad triangulation. But I would say that it's really not possible, because it's like taking a pixel picture and trying to get a better resolution on just one point to create a hole. So that's, I think, never really possible, because you will always destroy the existing mesh you have. So the only really way to do this is to do it with the NURBS workflow and get a new mesh. So you create the hole, and then the whole mesh gets created around that hole. I don't think it's really possible in any other way, at least not that I've seen any other approach. Yes, thank you.
That's it. I think that is the one I copy, no? There.
Yes.
Link. Perfect. So beautiful work, by the way, it says. Okay, so we'll wrap with that. Thank you again so much, Christian, for everything, for your
Thanks a lot.
experienced information and sharing your work and your workflow. And it's lovely to have you. And thank you again, everyone, for joining in another webinar. And I'll see you soon, and keep in touch.
Thanks a lot.
Bye.
Bye.